Okay, so already we've talked about binary, see, to decimal and back. I also want to talk about doing binary to hexadecimal, as well as binary to octal today. Alright, so if you want to go, by the way, from decimal to hexadecimal, it's probably good to just go via binary representation. I mean, you could go directly if you want, but I mean, if you already converted from decimal to binary, it's pretty straightforward to convert between these two and these two. This is actually the hardest conversion of the bunch. These two are pretty straightforward. Okay, so let's take a look at converting between binary and these two bases. All right, so let's take a look at the more useful one first. Let's look at binary to hexadecimal. So just to review, we have in binary, in hexadecimal we have 16 possibilities, because hex, remember, hex is just 6 in Latin and decimal. So decimal, or deci means 10, so 10 plus 6, that's 16. Huzzah. Okay, so in hexadecimal, let's just kind of go to the side over here, get some room here. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, sorry, not 10, herp. Instead of 10, we're going to say A. That should be A. So this is where it gets to hex, A, B, C, D, E, and finally F. Okay. So these are 16 possibilities in hexadecimal. Alright, so the equivalent in binary, by the way, is relatively straightforward. We just need to count in binary, so let's just do that. I'm going to count sort of the typical way. So I'm going to start out, I mean, I could do either from the most significant bit or the least significant bit, but the way I do this is this. I'm going to say, okay, I'll start from the least significant bit. So I'll say 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. So that's our 1 spot, our 2 spot, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1. Okay. And I have my 4 spot, 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1. Okay, and then finally our 8th spot. It's going to be 0, 0, 0, 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 1. And remember, when we're counting in binary, so those are 1s, our 2s, our 4s, our 8th spot. And the way we count in binary, just to review, we're alternating every other time, every 2 times, every 4 times, and every 8 times we're alternating between all possibilities. Okay. So, so this is the conversion between binary over here. So you have binary up here. So this is going to be binary. Whereas this over here is hex, a decimal, but I'll just say hex for short. Okay. So, all right. Well, So suppose I have some random number in binary. So let's just take a look at that. Suppose I have, like, say 1 1 0 1 0 0 0 1 0. Let's say 1 1 0. Say. Okay. Now this is not necessarily going to be. Yeah. So let's just look at this number here. If I have this number here, so this is our binary number. I'm going to look at this in chunks of 4. So I'll say I'm going to work my way from the least significant bit, which is this guy over there, all the way up to my most significant bit, which is this guy over here. So this is the least significant because it contributes the least to the number, whereas this contributes the most to that number. and I look at this in chunks of 4, right? Because I have 4 bits over here on this side for each hexadecimal number. So there's 16 possibilities, and well, 2 to the 16, sorry, 2 to the 4 is 16, right? That's why this works. So 4 bits represent 16 possibilities, right? So 2 to the 4 is 16. That's why we can do this. So I'm going to go from my least significant bit to my most significant bit. So I'll just look at this one. So we have 4 bits over here. Okay. And now, okay, so here we have 3 bits. Okay. All right. Now, if we have only 3 bits, what we should do is we should assume that there's 4 bits. We're just going to prepend this with a 0. So we'll say this is going to be a 0. The reason I say that is because we can always put 0 in front of a number without changing that number. So, okay. So 0, 1, 1, 0. So to do this conversion, right, I had to look up this in this table over here where I have all these numbers here. Now there's actually a fast way to do this. Really fast way to do this. If I just notice the pattern here, right, it's kind of like looking at like divide and conquer, right? You have a phone book, right? You never start. I mean. Now the way humans look in a phone book is not quite the same as the way a computer would, but if you start in the halfway spot and then decide which way to go, you can divide and conquer here. So I can do that here. So if I say, okay, well I know I have 0 as my most significant bit in this chunk here. So I have this chunk of 4 bits. The most significant bit in this chunk is 0. Okay. So I'm going to go look at 0. That narrows it down to these 8 possibilities. The next bit over here is 1, so that narrows it down to these 4. And 1, that narrows it down to, well, pretty much down to these 2, but I know the next bit, the least significant bit is this guy. So that's just 6. So I'll just write down 6 over here. So 0, 1, 1, 0 is 6. Okay. 1, 0, 0, 1, well, okay. I'll just go down to the 1, so these, okay. And I have my zeros, okay. So that's going to be one of these guys. And 0, 1, 0, 0, okay, and okay, great. So now I know it's this guy. Okay, so and finally I have 0, 1, 1, 0 again. So that's okay. That's 696. Okay, great. All right. So that's. By the way, this is not decimal. This is in hexadecimal. So one thing we should do in this class, by the way, is we should make the appropriate notation to say that we are in the right base. So I'm going to try and make sure to. For binary numbers, I'll say 0b, and for hex, I'll say 0x. That's a convention that's used in most programming languages. So if I say 0b followed by something or other, that's going to be a binary number. And if I say 0x followed by something or other, that's going to be hexadecimal. Okay, so we'll prepend our number. So this just signifies this is not decimal. This is just hex. And if I leave the number alone, we'll just assume it's decimal. Okay, so there you go. So let's try to convert a different number. So let's go the other direction. So that was, by the way, binary to hex. Okay. Now going the other direction is, as you can imagine, probably pretty straightforward. So here's another. I'll have a hexadecimal number, say 0x, and I'll just say something of interest to me. I am a dad. So there you go. This is a hexadecimal number. Let's convert this to binary. Okay. So what we do actually is just this. We're just going to go in this table over here and then figure out, well, what binary corresponds with that. So if I have this D here, well, that's just going to be this thing here, this number here. So that's 1101. Okay. And then for A, well, it's just going to be 1010. And finally D, well, we already did that, so it's just 1101. Okay. So there you have it. That's the binary. I mean, it's not much to this. Going between binary and hex is pretty straightforward. Now, if you want to look at something similar, like say between binary and octal, what we would end up doing is something very similar. Only instead of looking at 4 bits, we only look at 3 bits. Here's why. octal, by the way, is base 8, right? So if I want to represent 8 possibilities, I only need 3 bits, right? So 2 to the 3 is equal to 8. So I only need 3 bits to represent all 8 possibilities. In fact, if I look at just this part of the table, so if I look at just this part over here, right? Just this part over here. So this whole thing is hex. Maybe I should write this arrow over here, so hex over here, and erase this guy over here so there's no confusion. Okay, I'll do that. There we go. Okay, so if I look at these things over here, this is octal. And if I ignore the first bit here, and I just look at the remaining bits, so if I ignore the most significant bit, which is this bit over here, I'll just ignore that, and I look at the remaining bits, okay, I can do this conversion between binary and octal. So I'm kind of out of space. Let me just do this separately. So we did binary to hex and hex to binary. So let's just take a look. So we have we want to look at binary to octal and back. Okay, so if we have binary and octal, so we say, okay, well, so 0, 1, 2, 3, 4, 5, 6, 7. Okay, and then we have 0, 0, 0, 0, 1, 1, 1, 1, okay, 0, 0, 1, 1, 0, 0, 1, 1, and then finally 0, 1, 0, 1, 0, 1, 0, 1. Okay, so this is our octal, this is our binary. Okay, now if I have a number like, say, suppose I have the same number that I had before, so we have this, what was it, this number here, right? So let's just copy that around. Let's see, so I have, let's see, let's make sure I get this here. I'll select this number here, I'll copy that, I'll paste that number down, so, oops. So copy and then paste. Oh, well, I guess it's not working. Okay, well, never mind. What I'll do then, I'll move this around. So can I move that? Let's move that. Nope. Nah. Never mind. Okay, never mind. Okay, I'll just write the number down. Shouldn't be lazy. Okay. So let's just copy that number down the old-fashioned way. So I have 1101, 1010, 1101. This number here. This is dad, by the way, in hex. Now, if I want to convert this to octal, what I would do is I look at this in groups of 3, not in groups of 4, right? So I look at groups of 3, right? So I have 3 bits over here. And just as if, I mean, in this case we happen to have just the right number of bits here, but if this didn't exist, I'd have to fill it with 0. I mean, if there was a missing digit, like we had before. So we do the same thing. We just say, okay, well, instead of looking at 4 bits, we're looking at 3 bits. So 101, well, here we go. That's going to be 5. And this 101, 5, okay. And then 110, that's going to be 6. And then we have 110, that's 6. So this is 0, oh, this is, by the way, this is octal. So this is this number in octal. So there you go. 6655 in octal is going to be dad in hex. So that's how you can convert from binary to octal, and the conversion back is the same thing as before. Like if I had a octal number, like say I have the number, I don't know, 2, 3, 5, 7, right? Let's say we have this in octal, so let's convert that to binary. It's just fill out these things, just look up and plug and chug. So this is 0, 1, 0, right, which is this guy over there. 3, that's going to be 0, 1, 1, and then 5 is 101, and then 7 is going to be 1, 1, 1, 1 over there. Let's suppose I want just for fun. So that was binary to octal. Sorry, that wasn't binary. That was octal. That was octal, I should say, to binary. so suppose what I want to do is I want to convert this now into hex. So I would look at this, 4 bits at a time. Now I don't have my table in front of me, so this is going to be a little more challenging. So 1, 2, 3, 4. So we have 4 over here, and we have All right. So now I happen to know this is going to be F. The reason I can say that this is going to be all ones, right? So if I go back to my table over here, F is going to be all ones. We have a little bit of our table here. So, and 1110 is going to be E. So 1110 is E. Yep, that's going to be E. And then over here we have 0100. That's going to be just 4. Yeah. So it's 4EF in hex. So there you go. That's the conversion for you. It's really just looking up stuff in a table. If you have this table here handy, it's pretty straightforward. Same thing if you have this hexadecimal table over here, it's pretty straightforward. So there you have it.